guys, here's my project on crop classification with satellite imagery. So this is my poster for the project showing the final product. I'll go through some of the things I used to actually make this work, and then I'll go through the code and how it actually works, and how I got all these pictures here. So first, I was using EOLearn. So this is Python. So it has a bunch of different packages in here. We can see all the different packages down here. So it has specific packages for different things related to manipulating satellite imagery and getting out data. And this was created by Sentinel Hub, which is also the website I used to get the actual satellite imagery for this project. So I was taking satellite imagery of Ventura County, and the goal of the project was to take that imagery, place crop data on top of it, and then train a machine learning algorithm to then detect crops based on what it learned from this training. So I'll start going over the code now. So this is a Jupyter notebook. This is using Python. And then right here, I just have all the imports and setup. If we go down, we're going to start loading in the data here. So right here I have a GeoJSON of Ventura County. Then we're going to take that and split it up into boxes here. So we split those up, and then we're going to choose one specific patch in the middle. Here we see 156 is right in the middle, and then we're going to choose a selection of patches around that. So down here we're going to get band data. So there's different bands for the Sentinel satellites, and these are the ones we're going to focus on. So 2, 3, 4, 8, 11, and 12. And here's a little chart of the different bands and what they are used for. So this first one, NDVI, this is the Normalized Difference Vegetation Index. And I have a picture of this later on, but this, it shows the bands it's using. And this basically is going to be able to see the presence and density of vegetation. And down here we have some masks. So we have a cloud detection mask, counting valid pixels. And then we're also going to save that to an output. So this is going to save it as an EO patch once we're done. An EO patch is basically just a way to organize satellite data. Right here is where I actually load in the crop data. So if we check back on my chart here, I have a section right here with different crops loaded over Ventura County, just this small section down here. And then right here, this was a big problem with my project. It took me a little bit longer than I would have liked to figure it out, but there were some extra spaces in this file that they were causing a lot of errors with my program, and it took me a while to figure out what was going on. Basically, I just needed to remove some extra white spaces to make it work. So we did that. Right here, we're going to define the workflow. So we're going to add data, and then we're going to have our different bands. We'll have the valid mask, valid count, rasterization task, and then we'll save that. And then down here, this is where we actually set the time interval. So I set it for 2019 because if we check here, the crops I got were from 2019 as well. I chose a little bit shorter time interval. It's like a 2-month interval, just because I was trying to make sure I didn't use up all my credits. So I wanted to do that. So here we define additional parameters for the workflow, like the time interval, and then we're just basically executing the workflow here. This took me a while to figure out too. There was a lot of errors in this step, and it wasn't giving me very helpful error messages, so I had to do a lot of digging to figure out what was going on, and it ended up being just the white spaces. That was the biggest issue that I talked about earlier. So anyway, once you download all this, you'll have all the pictures, or I should say you'll have all of the EO patches, and then this section, what we're going to do with those patches is actually draw the images. So here we can see the images of Ventura County. So this is the crops for one square, and these are the crops for the entire section here. So now we have all the crops laid out, and we have the satellite data. And then down here, these two sections are for checking vegetation. So we're going to check the vegetation with the NVDI, NDVI mean. So right here we can see the vegetation for this section of Ventura County. And then here we're going to check the cloud probability for the pixels. And then down here we're going to define some more tasks So this is going to help us combine our features together, filter out more clouds, and erode each class, and use spatial sampling. So the erosion will help us get rid of errors in the map or gaps, and then spatial sampling will help us select a subset of pixels. Right here, we're going to define the workflow of all these tasks that we just set up right here. Right here, we'll actually execute that workflow and save everything to some new patches. And then we're going to load our patches and split them into a training set and a testing set. We see 80% for train. So here's our test patches and our training ones, any of the patches that are not in our test patches. And we're using GBM. If we check our imports up here, I'm actually using Light GBM. So here's more about Light GBM and how it works. So it's a gradient boosting framework that uses tree-based learning algorithm. So after training the model, we're going to use it. So we're going to load it and predict test labels. And then again down here, we're using a confusion matrix to assess the model's performance. This section right here, as you can see, there's figs here. They were supposed to be plots here and more graphs that I was going to show off, but I was having some issues with Jupyter Notebooks correctly displaying all the graphs and everything. Now we can see we're loading the EO patches in. We can see the cloud cover a lot better here. So there's a lot of clouds over this, and these are all of our EO patches for that same section we had before. So here we have another task. So this takes the model, the features, the output names, and then it actually performs the predictions on a given patch. And then down here we can see the actual result of the model. So if we see this, there's a lot of black, but for some reason it pretty much classified everything as truck crops that it couldn't figure out. A lot of these other orange sections it did get right, and then it had some grapes up here, so those are over here. Result. And then down here I have a zoomed in image of one of the patches. So this is the ground truth, what it should be. This was the prediction. So you can see it got most of it. I think up here it said 70%. So if we look right here, we can see 76%, 74%. So right here, we're getting a lot of the right idea, but there are some sections that didn't get correct. So anyway, there's a few things I could have done better, but overall this was a great project and I had a lot of fun. And it actually pushed me forward into another project that I'm going to continue on that's basically working on this same idea but with IoT sensors. And eventually I plan on combining the two together, so I want to make some type of company or project that uses IoT sensors, satellite data, and machine learning to analyze and look at basically the whole world. So I want to expand beyond just crops, but this was definitely a great starting point for me. And I had a lot of fun.